Jetlin. Say about preparative TLC, what we have discussed in the last class.
Sorry, ma'am. Last class absent.
Yeah, proceed.
Last class absent.
Then also you should have gone through the material, right? I have posted in the classroom, no? Google Classroom.
Mm-hmm.
Absent means you will be coming as such or what? Huh? That's what I have given time for 10 minutes to go through.
Yes,
Usually, what are the parameters we will be discussing under chromatography? We have come across paper, TLC, other chromatographies also, no? So, what general parameters you have discussed? Say any two parameters.
thin layer chromatography.
Yeah. Yeah, proceed.
Thin layer
Hmm.
chromatography.
Parameters. What is the use of thin layer chromatography? What purpose chromatography is applied?
Stationary.
Hmm.
And the stationary phase, ma'am.
Ah,
Parameter.
okay, next. What is one more
Uh,
phase?
mobile phase.
Hmm. Okay, pa. Read and come for the next phase, okay? Junaid,
Okay, ma'am.
Junaid, Mohammed Junaid, Mohammed Junaid, are you there? Jetlin, mute your mic. Thank you. Mohammed Junaid, answer for PTLC. Bharat, so Junaid and Bharat will get absent today, okay? Anybody else?
Good afternoon, ma'am.
Good afternoon,
Ma'am,
Shakti.
ma'am. Preparative thin layer chromatography principle, ma'am.
Mm,
Absorption chromatography, solid liquid chromatography, planar chromatography, ascending development technique, one-dimensional development technique, bicapillary reaction, open columnar chromatography, ma'am.
okay.
Stationary phase material glass plate, ma'am.
Mm,
Dimension of the glass plate 20 into 20 centimeter, ma'am.
mm,
Absorbent silica gel silica gel G.
mm,
Silica gel is a binder, ma'am. Silica gel is absorbent. G is binder, ma'am.
okay.
Method of uh, method of preparation is pouring method. Plate
Mm,
activity, time and temperature 1.5 and 110 degrees Celsius in hot air oven, ma'am. Thickness of PTLC plate is 2.0 mm, ma'am.
mm. Okay, pa, very good. Shaktivel, thank you.
Thank you. Thank you,
Mm,
ma'am.
Anybody else about mobile phase? Mobile phase selection under PTLC? Subhadarshini? Subhadarshini. Okay. Then Johnson. Johnson. Say about mobile phase selection in PTLC. Yeah, proceed.
Mobile phase volume maximum 100 ml.
Okay.
Mobile phase chamber now. Glass tank with stainless steel.
Mm.
Types of mobile phase polar and non-polar.
Mm.
Ideal chamber saturation time 20 minutes.
Mm. Okay, ma'am. Thank you. We'll proceed with the remaining parameters. Thank you. And Jetlin also good. Refer daily materials. That's why I'm posting after means recording your classes. I'm posting in the classroom. Those who are absent, just verify the or go through the video. Okay, and take down class notes if you want, or else read from the PPT. Junaid, in the next class you must answer. Okay. Okay, we'll proceed with the class. So PTLC is meant for isolation or purification. Isolation is nothing but from the separated molecules from mixture, a single molecule is getting isolated or purified to get a single molecule without any other interferences like any other molecules, related molecules or impurities from which we are purifying it or isolating out a particular compound. Okay, for that purpose, preparative TLC is applicable. And principle, as already discussed, adsorption, solid, liquid, planar, ascending development, one-dimensional development by capillary action, and it is also called as open columnar chromatography. In the stationary phase, we have discussed material used, dimension of the plates, and then adsorbent, what is adsorbent is used, then method of preparation of plates, plate activation time and temperature, what is the need of plate activation time, and why we need to maintain the temperature of 110 degrees Celsius, then what thickness for PTLC plate, then particle size of adsorbent, what is its role, role of particle size in separation, then shape of the particle, then plate height, what is plate height, and the role of plate heights also we have discussed. Then under mobile phase, types of mobile phase chamber use, mobile phase volume of for PTLC, then saturation, it is common for TLC and PTLC. Then next we'll move on to the third parameter, sample application. Once the stationary phase and mobile phase is ready, next we can apply the sample. So how people prepare sample and what type of sample is preferred? So any pharmaceutical samples, drug samples of milligram to gram range can be applied. Milligram to gram range. Note down the concentration range. From milligram to gram range we can apply for the PTLC plate. If we apply in the gram wise, one spot should be containing milligram to gram. So that only we can isolate more amount of sample. So concentration of sample for PTLC is high comparing with TLC and HPTLC. Then application device, either use capillary tube or micropipette. Concentration of spot, if you are using micropipette, it may be comprising 10 microliter to 1 ml spot. For a single spot, we can apply up to 1 ml. Minimum of 10 microliter can be applied. Markings you can make with glass marker on the glass plate, at the back side of the plate. Then spot shape will be circular. So when you are keeping a drop of sample, it will be spreaded as in the circular format. So you will get circular shaped spot. Okay. So these are all the important points under sample application. What are the points? Concentration of sample, what concentration we need to select, and after preparation of sample with that particular concentration, and it must be, the sample must be prepared with mobile phase solvent only in the solution form. How sample will be taken is in the diluted form with the solvent, mobile phase solvent only. It should be dissolved, okay, and it should be solubilized with the mobile phase solvent, and that solution is taken to get milligram to gram concentrated sample, and that sample is placed over the plate for separation. And application device is either capillary tube or micropipette. Capillary tube, we cannot measure how much ml we are taking in the capillary tube. Since it is applicable for qualitative analysis, we can approximately place a drop by using capillary tube or micropipette. Micropipette, we can measure how much volume we are applying. So when you go for quantitative analysis, we can go with micropipette with the measured volume of either 10 microliter or up to 1 ml we can spot. Then marking should be done with a glass marker. Spot shape will be circular. This is about sample application. So once the sample is applied, we need to dry the plate under either under air drying only, under room temperature only, we need to dry the plate after sample spotting. If you heat in hot air oven, what happens, the sample will be, there is a chance to destroying or degradation of sample at that particular temperature. So at ambient temperatures only, we need to allow the plate to dry. The samples to get dried. Once it is dried, it is ready for placing in the mobile phase for development, and it is always kept in the slanting position in the mobile phase chamber for development. What are the development techniques? Is followed in TLC. Commonly ascending and one-dimensional technique is followed, and solvent rises by capillary action. And then development time for PTLC, it varies from 30 to 200 minutes according to the environmental conditions and solvent nature, sample nature, and the thickness of plate. Development time, that means to reach 3/4 of the distance in the stationary phase, it takes 30 to 200 minutes, half an hour to 200 minutes it takes. Okay, then for TLC, when comparing with TLC, it takes only 20 minutes, maximum of 20 minutes for development in the glass line, where glass plates requires more time for development. Since it is having high thickness comparing with TLC, where TLC is having 0.2 millimeter thickness and PTLC will be having 2 millimeter thickness, so that development time also will be high for this. Then drying after development. After development, drying is 40 to 60 degrees Celsius. This is the optimum drying only. If you cross the temperature above 60 degrees Celsius, then the sample will be definitely go for degradation. So you will not get active molecule in the separated form. So we can apply this particular temperature, that is 40 to 60 degrees Celsius for 5 to 10 minutes. If you heat, your plate will be dried completely, and the same condition for TLC is 2 to 5 minutes at 40 to 60 degrees Celsius. When this temperature is applied for drying after development, where after spotting the sample, how you have to dry at room temperature only, at ambient conditions. But after development, the solvent must be dried completely to locate the sample spot. For that case, we need to dry at 40 to either 40 between 40 and 60 degrees Celsius can be dried for 5 to 10 minutes only, not up to 30. Activation temperature is different, drying temperature is different. Activation temperature is what? 110 degrees Celsius to 1.5 hours, 30 to 1.5 hours, based on the technique what you choose. Where drying with the sample is, you have to be very cautious by setting the temperature. If you are heating with the sample, then it should not cross 60 degrees Celsius. And to timing also 5 to 10 minutes only. If it is not dried, you can allow more than 5 minutes. Otherwise, in 5 minutes, it will be get dried completely. The next one, deduction of spot. So after development, then we'll be going for the deduction, where the sample, separated sample is located on the stationary phase. Once it is dried, then the plate is taken for deduction. What deduction here is preferred? Since we have to recover the sample for isolation, since the technique is applicable for isolation, we have to recover the sample. For that case, we have to go with non-destructive method only. non-destructive method, that is fluorescence detection. This is the UV cabinet used for fluorescence detection, that is UV chamber or UV cabinet it is called. So inside the UV chamber, this is the door where we can open and keep your stationary phase plate inside it. This is the lamp, UV lamp inside you can find. This is the visualizer through which we can see the fluorescence light on the plate. Okay, here glass protection will be there so that light radiation will not affect your eyes while observing the color spot. So this is UV cabinet you will find in our lab also for finding fluorescence spots. Then you can locate the spot or mark the spots by means of pencil. Then you can go with RF value calculation for detection. What sample it is. Okay, so how the detection of spots is done for PTLC by non-destructive UV chamber method, either at shorter wavelength or longer wavelength. Shorter wavelength is 254 nanometer, longer is 366 nanometer. And the method is called as fluorescence detection. Since your sample will emit fluorescence light at particular wavelengths, either shorter or longer, the method is called as fluorescence detection method. Okay, so once it is detected, the particular, if you are selecting RF value, like 0.1 or 0.2 your sample is giving, then at 0.2 whatever sample is giving the fluorescence with the same fluorescence is scrapped out from the plate and it is recovered from the silica gel, that is adsorbent from the silica gel. Sample is recovered and it is used for further processes like characterization, what molecule or what chemical structure it has. For further characterization we can take the sample. So for that purpose PTLC is widely used. It is simple and easy technique for recovering the sample for isolation. Okay. And next about qualitative parameters and quantitative parameters, detection of spots by using qualitative and quantitative parameters. Here qualitative parameter is RF value. Even we can go with semi-quantitative analysis by seeing the density of spot, by means of densitometer. Concentration versus density of spot can be analyzed to know about quantitative parameter. To make a quantitative analysis. Okay, RF value is qualitative parameter. We have discussed enough regarding RF value, so that is only used for detection of the compound according to the distance traveled by the sample from origin line and distance traveled by the solvent from origin line to solvent front will give you the RF value. So this is the distance you have to leave from bottom and the top portion also. Here mobile phase should not cover the baseline, it should be below the baseline. So you have to leave enough distance for drawing the baseline. So this is about calculating RF value. So with this PTLC gets over. PTLC isolation is done by means of scrapping method from the plate. The silica gel will be scrapped out. Okay, and then the sample, wherever the sample is giving the same fluorescence and same RF value is marked like a band, we have to mark, and then it is scrapped off with a spatula. By means of spatula we can scrap out this, and silica gel is inert, no, it will not interact, it will be reversible interaction only. You will not change or alter the chemical nature of your sample. So only adsorption takes place, not absorption. Sample easily can be recovered by means of filtration with a particular solvent. You can dissolve your sample by using any solvent so that and filter. The silica gel will be retaining, your sample will be collected with the solvent. Then you can process the sample for further characterization processes or biological activity, whatever further processes you can use your sample. So this is how PTLC is applicable for isolation purpose. Okay. It is simple only, same parameters only we have discussed like TLC, stationary phase and mobile phase selection. Some values will be changing that you have to note down. Here I cannot make a tabular column for comparison. First I need to explain all the parameters. That's why I have given separately. But you have to read comparatively with the TLC. Okay, where material used in TLC was glass slide. Here glass plate. Dimension was only 7 centimeter. Here 20 into 20 centimeter. And adsorbent is same. Method of preparation also same. Activation time is varying since the plate is having more thickness. And there 30 minutes, here 1.5 hours. So temperature is same. Thickness of plate, there 0.2 millimeter, here 2 millimeter. Particle size will be same, 5 to 25. And these parameters are same for TLC and PTLC, spherical and 30 micrometer. Where mobile phase also same. Here glass tank we are using, there only glass beakers, 2 ml beakers are used in TLC. Their volume is 10 ml, here 100 ml. Saturation time also same. So comparison and difference will be there. So if you read comparatively, you will get very clear idea about TLC and PTLC. TLC is applicable only for identification, separation and identification. Here it is used for separation, identification and then isolation also. This is next level comparing with TLC. Here concentration is milligram to gram, where in TLC microgram to milligram concentration range. In application devices same, concentration of spot there only in microliters, maximum of 10 microliter will spot, here up to 1 ml we can spot. Markings and spots shape both are same only for TLC and PTLC. Positioning, this is also common for all the techniques. And here development technique is same, development time is varying. Here I have given the comparable time also, 10 to 20 minutes for TLC, where 30 to 200 minutes for PTLC. Then 2 to 5 minutes for TLC for a while heating after development, here 5 to 10 minutes. Based on the thickness, we are increasing the timing of drying. The temperature is 40 to 60 degrees Celsius. It is common for all the techniques. Then deduction, either in TLC, either we can use reagent method, destructive or non-destructive method. Since we are going for only identification, here we are going for isolation, so we cannot destroy the sample. So we are going with non-destructive method. Okay, that is fluorescence deduction method. What is shorter wavelength? 254 nanometer. Longer wavelength? 366 nanometer. Then identification parameters, qualitative parameter is RF value, and the ideal RF value is below 1, that is in fractions, 0.1 to 0.9. Quantitative parameter, we can do a quantitative analysis also with the sparks by using densitometer. That also will say about optical density. We'll be passing radiation, same process like HPTLC. We'll be discussing in HPTLC how quantitation actually is done, but by using the plate concentration of sample also, we can find we can say the concentration of zone, the size of the zone also will tell about the concentration. So likewise, we can go with quantitative analysis also, taking the parameters concentration versus density of spot. Thank you all. A very happy new year to all. The next we'll be discussing about
Happy New Year, ma'am.
Happy New Year to all. Thank you.
Thank you, ma'am.
Happy New Year, ma'am.
Thank you, ma'am.
Thank you.
Thank you.
Happy New Year, ma'am.
Happy New Year.
Very happy New Year. New Yearல எல்லாரும் மீட் பண்ணி டைரக்டா மீட் பண்ணலாம். ஓகேப்பா. Any doubt in this?
No, ma'am.
No, ma'am.
Jacqueline? Okay, no doubts. Okay, pa. Thank you.
Thank you, ma'am.
Shall we leave the class then?
Thank you, ma'am.
Okay. On 4th, you will be having HPTLC class. Okay.
Okay, ma'am.
Okay, pa. Thank you all. Enjoy New Year.
Thank you, ma'am.
Hello. Hello.
Hello.
Yes. யார் யார் இருக்கா?
ஏடா எங்கடா இருக்க மண்டா?
நானா விளையாண்டுருக்கேன்.
விளையாண்டியா? வேற லெவல் போ, வேற லெவல்.
கிரிக்கெட் விளையாண்டு.
இரு,
என்னது போட்டு கொடுக்குறியா?
அப்படின்ட்டு அனுப்ப முடியாது.
சரிடா சரி வீடியோ
வீடியோவா?
ம்
வாய்ப்பில்ல. நீ ஸ்டார்ட் பண்ணல, நான் ஆன் பண்றேன்.
நான் பண்றதா நான் பண்ணி யார பசங்க விளையாடுறப்பா
விளாடுறியா?
ஆமாப்பா
ஏய் ஜீவிடா ஜிராடி எஸ்கேப் ஆயிட்டான்டா. ஐயோ காலு.
சரி அப்புறமேட்டா பேசுறேன்
சரிடா பாய்.
சரி பாய் இன்னொருத்தன்
எனக்கு
தீபா
வேலை இருக்கு.
ஹலோ அவனடா பேச முடியும்
அவன் நம்மள மாரி கிளாஸ் போட்டு போன தூக்கி போட்டு நான் அப்படிதான்டா ஒரு சைடா பண்ணுவேன். சிவசக்தி சார் கிளாஸ்ல அப்படிதான் பண்ணுவேன்.
ஸ்கிரீன்ஷாட் எடுத்தியா இல்லையா
லேது.
நெக்ஸ்ட்
ஏய்
கிளாஸ்
ஏய் நான் வந்து பேசிட்டு கிளாஸ் பாத்துட்டே இருந்தா திடீர்னு ஒரு நாய் நடுவில் கால் பண்ணி வாடா வெளியே போலான்னு கூப்பிடுறான்.
சரி ரஃபி வந்தானே
ரஃபி கிளாஸ்க்கா? கிளாஸுக்கு தெரியல, பாக்கல.
ஃபோன் வந்துச்சுன்னா வீட்டுக்கு வரமாட்டான்.
ஓஹோ ஐ சி. நீ அவன் போயிட்டான்டா. என் பக்கத்துல எல்லாரும் ஒட்டு கேட்டிருக்கான்டா.
இருந்தா பேசிருப்போம் இருந்தவன கலாய்ச்சி
நம்ம வந்து பரம ரகசியம் பேசலப்பா. இன்னைக்கு நினைச்சு பாரு, நல்ல வேலை நான் எல்லாம் சரிண்ண என்ன நடக்குன்னு தெரியல. குரூப்ல போய் ஸ்கிரீன் ஷாட் போட்டுட்டேன்.
எந்த குரூப் நம்ம
என்ன சத்தியமா எனக்கு தெரியல. சரி அனுப்பி விடுவோன்னு சொல்லிட்டு அனுப்பி விட்டேன்.
ஆனா
அது
அதான்
ஜானுக்கு இது யாருக்கு யூஸ் ஆச்சா இல்லையா, ஜானுக்கு அது யூஸ் ஆயிடுச்சு.
போயிருந்தனா
சேர பாரா செஞ்சு ஆ